know biconditional statement, we should know what is exclusive OR. EOR we say, R we put and a bar on that. So exclusive OR is just the reverse of this. Here we said both are true or both are false. My answer is true. This exclusive OR tells me not both. That is, both are true or both are false. My answer is false. So for this I will write the reverse. F, and this is also F. In between I have T. So both are true. My answer is false. Both are false. My answer is false. So what do I understand? Not both. Exclusive OR tells me not both. One is T, one is F. My answer is true. One is F, one is T. Also my answer is true. So let us remember, for exclusive OR, the code word is not both. Any one I can put immediately true. Now, having done many logical statements, when we see the final table, if the final table contains only T or if the final table contains only F, do we have a special name? Yes. For example, what is P and negation P? What is negation P first of all? Change. Negation P will be F, F, T, T. What about P and negation P? P and negation P, my answer F, F, F only. So all the answers are F. I will call this as contradiction. If I get only F, I call my answer as contradiction. Call it as F, double coded F, call it as contradiction. Suppose my question is PR negation P. PR negation P gives me 1T, 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 1T is there. Even if 1T is there, my answer is T. So PR negation P, all the values are T. Such a statement I call tautology. So tautology tells me the truth value is always T. So what is the example? PR negation P. One example I can give. For contradiction, I will say P and negation P. What about these statements? They are not containing all to be T or all to be F. T and F are mixed and matched. So such statements we call contingency. So what do you mean by contingency? Neither tautology nor contradiction. I declare the name contingency. So tautology, fully true. Contradiction, fully false. And contingency, it can be both. True, false, anything may come. So a statement that is neither tautology nor contradiction, we call as contingency. Suppose I give you two statements. Both the statements have same answer. We declare the statements to be logically equivalent and we put this symbol. So what do you mean by logically equivalent? The statements in LHS and RHS are equal. They contain the last column or the final answer, one and the same. We call the statements to be logically equivalent. Now the question is, can you interchange and are? So the symbols we have and are. If I interchange these two, we give the name duality. So the word duality tells me and are interchanged. So for example, for tautology, contradiction will be the dual statement. For contradiction, tautology will be the dual statement. So in logic, we can also interchange and or, and we give that principle as duality principle. Let us continue with exercise problems. Question number 7. Verify whether the following compound propositions are tautologies or contradictions or contingency. P and Q and not P or Q. PQ, as we know, we can write double T, double F, single T, single F. P and Q, both are true, it is true. The remaining cases, it is false. P or Q, both are false, it is false. All other cases, it is true. Not P or Q. So this we are changing P or Q. So it becomes F, 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 T. So T comes F, F comes T. Now P and Q and not P or Q. That is, these two I have to check. T, F. What symbol? And. And tells me TF will become F, FF will become F, FF will become F, FT also becomes F. The last column contains only F. So it is a contradiction. Let us frame the sentence. Since the last column contains only F, the given statement is a contradiction. Second subsection, P or Q and not P implies Q. So to check this, let us start from the innermost bracket. I need to find out P or Q and then not P and then P or Q and not P, then implies. So P or Q bracket and not P bracket implies Q. So let us find out one by one. P or Q. What is the condition? Both F, my answer is F. Other cases it is true. Not P, just change and write. T becomes F, F becomes T. P or Q and not P. So these two. And tells me both are true, alone true. So this is false, false, true, false. The next idea. From this, I must say implies Q. So to avoid confusion, let me write Q here. What is Q actually? Q is TF. What should I remember? For implies symbol, it must be tough. Check whether anywhere tough is coming. That is TF. So check TF is not there. T starts, F ends. No, no. So nowhere I have TF combination. So all the answers will become true. Remember, if TF comes, my answer is false. But T comes, my answer is T only here. So all the entries become T. The last column contains only T. The given statement is a tautology. Remember, if the final column contains only T, true, my answer is a tautology. And if it is fully false, it is a contradiction. Third subsection, P implies Q. First we will find out that not P. Next step, not P implies Q. Next step, and then P implies Q, double implication, not P implies Q. So let us do one by one. P implies, this symbol we must remember tough. So TF becomes F. All the remaining will be true. Not P, change and write. T becomes F, F becomes T. Not P implies Q. So let us write Q again. What is Q? TF, TF. Implies symbol tells us if both are, implies symbol tells tough. So TF comes, my answer is F. TF is not present here. TF becomes F. All the remaining will become true. The next idea. P implies Q. This column. Not P implies Q. This column. Both together we must see for biconditional. What does biconditional mean? Both are same. My answer is true. So TT, my answer is true. FT, they are changing, so false. TT, my answer is true. TF, they are changing, so my answer is false. Now, here I have T as well as F. So, it is neither a tautology nor a contradiction. So, what word we suggest for that? Contingency. The last column contains T and F. Both are coming. The given statement is a contingency. So whenever they give you determine whether it is a contradiction, tautology, contingency, take and write why you declare the statement to be a contingency. Because it contains T as well as F, we call it as a contingency. Question number 7, fourth subdivision. P implies Q and Q implies R. Together implies P implies R. So to find out the innermost bracket, P implies Q. Implies tells me tough. So TF becomes F. P to Q. So check like this way. Here I have TF. So it is F. TF becomes F. Nowhere else. So all the remaining are true statements. Only where you put F, TF becomes F. Next I need to find out Q to R. So Q implies R. Again you check TF. Here I have TF, so it is F. Here I have TF, so it is F. And all the remaining will be true. The next idea, we need AND. So P implies Q and Q implies R. These two we must check for AND symbol. AND tells me both are true, my answer is true. All other cases false. Both are true, my answer is true. As we have completed, next we need to find out P to R. P implies R. So these two I must check. Remember this symbol tells us TF becomes F. So the remaining cases true. TF, it is F. True. TF, it is F. All the remaining cases will be true only. Now we need implies for these two. So P implies Q and Q implies R. Both together implies P implies R. As we simplify the answer, implies. Implies tells us again TF will become F. The remaining true. So TT, FF, FT, FF, TT, FT, TT. So nowhere I have TF symbol. After T I must get F to put F. After T there is no F. So the entire column contains only T. Declare the statement since the final column contains only T. The given statement is a tautology.